Dear students at Salawa College for Science and Technology, welcome in the 8th lecture of XPR Systems, which will be titled Rule-Based XPR Systems. The lecture objectives: what is rule-based XPR systems, structure of rule-based XPR system, rules in rule-based XPR system, and lastly, advantages and disadvantages of rule-based XPR systems. Rule-based XPR systems based on if-then rules to process information and make decisions. As we know, if-then it is one of the programming language statements like if in Java, if in C, and if in C++, if condition, if logical condition, and if nested conditions, and so on. But here is treated as a rule because it is compatible with rule-based XPR systems. These rules are typically crafted by domain experts and serve as the system's reasoning mechanism because it suitable for reasoning, suitable for logic, because if consists of two parts: if then, if something then something, and the first something will be logic, and you can reason from the first something. Before then you can make a reasoning mechanism to get a logical result. If, as we say in the next slides, consists of two parts: if part and then part. If part represent like a question. When you ask something, you may wait for the answer, or if represent the question and then represent the answer of the question. A well-known example is Mycin, an early medical diagnosis system that identified bacterial infections. Why a well-known? Because, as you know, in XPR system, especially in medical diagnosis system, it includes tenses of if-then statements, because that can be a good example for rule-based XPR system. For example, if patient is feel by fever, if patient with high pressure, is patient something, then something. If patient feel with headache, is then it maybe have a fever, something like this. The Mycin, surely I am not saying Mycin, but if you open Cyclopedia or open internet as General or Britannica, you can find many information about Mycin. Surely it includes many if-then statements. A rule-based system is a type of artificial intelligence that uses a set of predefined rules and logic to make decisions and solve problems. As I said in previous slide, if-then as a rule, it is suitable for logic because it consists of two parts. It consists of condition and then the answer of condition. It consists of primarily, as I said, of two components: a set of rules, inferences, and a database of facts and premises. That is mean, for the system of rule-based system, there is rules, and then the system, according to specified mechanism, make inferences according to the existing databases. That is mean, you enter the database or the facts or the knowledge, construct the knowledge base for the system, and the system make search in this knowledge base and then make reasoning according to the answer and give you the optimal solution, as I said in the previous lecture when we explain for you knowledge-based experience system. Here is the structure of rule-based experience system. We can explain this by more details. Let us select the brush or the brushes. Like other experience system, like shell experience system, like base experience system, they are common components. For example, inference engine, which is found in the previous type of experience system, which is knowledge-based experience system. For example, user interface and knowledge base, or here called knowledge engineering. The new things here is the fact. We have a database. This database includes many facts, and you can formulate this fact according to the nature of the system or to the environment of the problem or the domain of the problem. And the second important thing is the rule. The rule is if-then. As I said, this is not only the rule in the rule-based experience system, but you can easily formulate. Why is the pressure not work? But you can easily formulate other rules by using if-then statement, and you can let the computer to generate other facts according to this rule. For example, bigger of x and y, bigger of x comma y, and if you put in the fact in the rule x comma y, and here bigger, the rule is bigger of x y, and you can put in the fact x is equal elephant, y is equal horse. That is mean x is greater than y in the rules, and that is mean elephant is greater than horse, and you can extend put y, and if x is greater than y, also x is if x is greater than y, then x is greater than z. For example, elephant is greater than monkey, and so on. And let the computer generate many rules. As I said, if then it is not only the only one rule in the rule-based system. That is mean the expertise, the experts, or the programmer or the knowledge-based engineer can generate or can formulate many rules and let the computer add new facts and new results. The new things also in this structure is external database. Maybe you need to make a normal database as an external database, like information about the patient, information about the hospital, the name of the hospital, the name of the doctors, the name of the patients. This is a database, and you can make this database, or you formulate or convert this database in a program which is called new program. That is means the inference engine receive for input, receive facts, receive rules, receive external database or normal database, and then receive the output or the results of external program. And then this inference engine connected with other explanation facilities and with the user interface and developer interface, and the main important thing is connected with knowledge engineer or knowledge base. When you ask a question, for example, the system search in the knowledge base and ask and give you the answer. Like now this became very easy when, in the internet. Now if you ask Google about any question, you can find the answer. For example, open and ask AI question. Ask and answer in AI. Okay. Here you can enter your question and you can receive your answer. For example, you can select this ask AI study questions and answers. You can easily ask question is here. For example, find me CS job, and you click here to the next step. You interact with the interface. You can get university, enter your university and click here and then send and so on. Return to our PowerPoint. This is, as I said, this is the structure of XPR system, and as I said, it is similar to base rule, to the knowledge base XPR system and to shell XPR systems. Rules in rule-based XPR system. The term rule in AI is the most commonly used type of knowledge representation, can be defined as in an if-then. As I said, the basic rule in AI or in rule-based XPR system, if-then. And it consists of two parts. If part, to the some action in the system, and then part. If something, there will be action here, and then in the then part there will be another action. Any rule consists of two parts, as I said. If part called antecedent or premise or condition. Here is assumption according to the first part. The second part will be formulated. All the system, all the XPR system answers the question according to the condition of if. As I said, in the normal programming language like Java, there is if condition, because that there is a condition and then is the answer of that condition. Then part called the consequent conclusion or action. That is mean consequent. That is mean is a part, is a built-in in then part, in then statement. Rules provide some description of how to solve problems. That is mean you will determine what are these rules, what are the description to solve the problems. Rules are relatively easy to create and understood, because XPR systems as general, it is related strongly with the natural language, because that the question or the rules are understood, are understand for the system from one side and to another side, surely understand by the expert or by the human. The human mental process is internal. That is mean the human mental or the human brain, it is too complex to be represented an algorithm. It is difficult to represent the human information which is in the brain of the human in the computer, because the human brain consists of many cells, of millions of cells, and each cell include DNA, deoxyribonucleic acid, and this DNA include many encrypted or information represented by 0, 1. However, most experts are capable of placing their knowledge in the form of rules for problem solving. Despite of this complex, some experts trying to convert or to decrease the complexing in making the rules. For example, if the traffic light is green, then the action is go. This is a logical phrase or a logical text, and it can easily convert it to the rule, because we can convert the four words the traffic light is in one variable, for example in x, and we said if x equal green, or if x is green, then go. Without the action is go. Here 3 words and here 4 words, and we can easily convert the natural language which will be understood by the human, can be converted to a form understood by the expert system. If traffic light is red, surely logically stop, because the red color for stop and the green color for go. Here another examples of if then, and we can explain this by more details. We can go to paint and then select brushes. Here we can see here if age of the customer less than 18 and cash withdrawal greater than 1,000, then signature of the parent is required. This is a mix or a hybrid of two types of operators: mathematical operators and logical operators. Less than 18, this is a mathematical operators. As you know, mathematical operators depend or based on mathematical digits and numbers and signs. For example, here is the less than sign, but mathematical operator include other signs like greater than, less than, equal, less than or equal, and also compound with logical operators. As we know, logical operators include 3 types of logical operators and or not, and it gives us one of 2 values, true or false, according to the type of the operator. According to the type of logical operator, it gives us true or false. And we use these operators, logical operators and mathematical operators, in the rule-based expert system, which is if then. If age of the customer less than 18 and cash withdrawal greater than 1,000, that is mean according to the AND operator, that is mean this side must be correct and this side must be correct, then the result will be correct. For example, or this if part must be true, and then and the part come after and must be also true. This will be true. When this is true and this part is true, at that time the phrase or the part come after then will be true. That is mean at that time we need the parent, the signature of the parent. This is the use of mathematical operators and logical operators in rule-based pair system, and we return again to our lecture. Operators such as is, are, is not, are not, are used to assign a symbolic value, as I said. Can instead of use a phrase here, you can use only true or false, or even you can use 0 here and 0 here and 0, 1 or 1 to 1 according to the combination of these operators. Also, if-then rule can be used with relations. For example, the fuel tank is empty, then the car is dead. That is mean if the fuel tank is not included a fuel, if the tank is not included fuel, that is mean is empty, and then the car will not go. This is a logical and understood for the human, but we can easily make a symbols or convert this text to the symbol. For example, here in the first part of if, you can easily exchange, or why the mouse is not work, put fuel tank is empty, put X here, and the car dead, put Y here. If Y is empty, if X empty, then Y, and so on. If the season is autumn and the sky cloudy, and the forecast is drizzle, then the advice is to take an umbrella. This is a logical expressions, and these expressions can be represented. Firstly, you can represent by symbols X and Y. Secondly, you can represent them by mathematical operators and logical operators according to your system. Next slide, also the strategy. When according to the previous result, for example, the car is dead, we take this result, and if the car is dead, we have another action. This action, check the fuel tank, or this may be one step, and the second step, check the battery. And this program can be include other steps. Step 3, check the tire, because when we see the orange light in the car system, that is means there is a problem. Maybe the tank is empty, maybe the battery is not work, maybe the tire is not full, and so on. There are many phrases, or there are many statements, and you can easily convert them in the form of symbols like X and Y, and the form of operators like mathematical operators or logical operators. Also, this is a similar example. The spill is liquid. The spill of hydrogen is less, and the spill of hydrogen liquid less than 6, and the spill is smell in vinegar. Then spill material is acetic acid. This is the result of then, and this is the condition. and maybe also include logical operator. Here we see mathematical operator less than 6, and maybe include and with another mathematical operator. If like here, if spell pH less than 6 and maybe include another operator here, instead of using and, we can use not, we can use NAND, we can use or any type of logical operators. Advantages of rule-based expert system. Rule-based expert system offer benefits of explainability, meaning the decision-making process is transparent due to the predefined rules. According to the predefined rules and to the facts, the problem solving or the meaning of the decision making will be most accurate. They are straightforward to implement, often efficient for automating tasks in well understood domains. Always, as we explain in the forward scanning and backward scanning, you can implement efficient technique to get task and to implement the task and get results, and computationally less expensive than creation other eye techniques. Last slide. Disadvantages of rule expert systems involve ambiguity, include ambiguity. It is not clear sometimes, requires learning from experience. That is mean you must let the machine learn from experience. That is mean you must give the machine a narrow base, a narrow knowledge base to learn. Difficult to maintain. That is mean to correct the errors, making incorrect submissions. That is mean the results sometimes it is not correct, in addition to complex systems. Dear students at Salama College for Science and Technology, I intend to take a case study according to my experience, previous experience in designing medical diagnosis systems, but due to the current situations in our country, and it is difficult to make a practical online, I advise you to open YouTube and search for any topic and try to make unexpert systems. I intend to give you practical lectures. They are 4 practical lectures. I will upload them in the Moodle, but because some students have no internet, have no devices or computers, it is difficult to practice. But I will try to explain for you in 2 lectures or in 3 lectures the practical part. But the exam will be in these 8 lectures about expert systems, and the exam will be theoretical only, and the types of questions they will no right questions, will be multiple choices, A, B, and C, true and false, match, and questions like this. Thank you very much. I hope you good successful in the examinations.